So as we saw in the previous example, if we take the advection equation with growth or decay term and we transform it using the characteristic curves c equals x minus ct and tau equals t, then this becomes the new partial differential equation, which is actually just an ODE in tau. All right, so let's look at solving an explicit example. So suppose we're given the equation u sub t plus 2ux minus u equals, and we'll take our forcing function f, our sinks and sources, just to be t. Then we would use the characteristic curve x minus 2t, and this would be converted into the new equation, and tau equals t. This would be converted into u sub tau minus u equals tau. And so we look for an integrating factor, e to the integral of this term is right here's coefficient, which is -1. So we have e to the minus tau as our integrating factor. So we multiply e to the minus tau all the way across this equation. And then on the left side, we should have the derivative of the integrating factor times u. And on the right side, we've just got tau e to the minus tau. Okay, so then we can go ahead and integrate both sides of this equation. And on the left side, the integral just strips away the derivative, so we have e to the minus tau times u equals, and then on the right hand side we have to do some integration by parts, and you end up with -1 minus tau e to the minus tau. Oh, sorry, that's a positive sign there in the middle. And then you also get some constant of integration, but remember we're in a PDE class now, so our constant of integration can actually depend on xi, because if you go backwards, the previous step right here, this would be differentiating with respect to tau, and that would well and truly kill off this term g of xi. So we need that there. And then the last part is just to take this guy and move him back to the other side. So we multiply across by e to the tau, and we have -1 minus tau, and then e to the tau is going to cancel the e to the negative tau right here, so that will go away. And then we'll have g xi e to the minus tau. All right, and so then converting back to regular coordinates, our u of xt then is going to be -1 minus t plus g of x minus ct e to the minus t. Oh, and I forgot, our c is equal to 2, so let me just make that correction. There we go. Okay, and so there is our solution for that advection PDE.